Okay, great. Thank you very much for being here. So my name is Angelika. I'm an EPFL PhD student. I'm in my 4th year, and my PhD is on artificial intelligence and more specifically natural language processing. So today what we're going to see is how we can evaluate large language models, LLMs, on specialized domains like the domain of finance. So how many of you have used ever like ChatGPT or GPT-4 for your work, even like creating an email or creating a paper or something? Okay, cool. Maybe you want to rephrase some things, right? So in this example, let's ask GPT-4 this example. So we ask basically if the CEO of First Republic Bank, if have not gone on medical leave, how would have that affected the bank? So basically what the model says is that the CEO played a pivotal role in terms of decision-making and strategy, and basically what it concludes is that his presence might have offered stability. So it's not something very wrong with this answer, but we have two things that they're not quite okay. So the first one is the vagueness. So the answer is a bit vague. That means that the reasoning steps are not very clearly stated. And the second one is that basically there might be more contributory factors. So let's say the changes in the interest rates in 2023, okay? So this is not part of the context. So we see that the model really struggles in synthesizing information in order to derive the answer. So besides GPT-4, we have also other models like Bloomberg GPT. I think Bloomberg is on the scale of 50 billion models. And we see in these simple tasks like sentiment analysis, name entity recognition, and financial QA, we see pretty much that the models, some of them perform well in some tasks. These are from famous data sets. You can check this paper. But overall, we see that even in these tasks that they're much more simple than the case that we saw on the left, these models, they struggle to perform well. So what we're going to talk about today, we're going to talk about how we can design these LLMs and enhance their abilities, or let's say align them to specific domains, like the financial domain. And then we're going to assess these models in terms of the complex reasoning abilities that they have. In order to do that, I'm going to talk about a project that I was very happy to be part the last 8 months, which is the Meditron model. I don't know if you have heard about it. So it's a domain-adapted LLM on the medical domain. Okay? So we're going to basically draw conclusions from this project in terms of what is the best pre-training data mixtures that we can use in order to achieve high-quality training. What are the challenges that we face when it comes to continually pre-train these kind of models? And finally, how we evaluate these models, both in domain-specific tasks, but also in general capabilities of LLMs. So let's start. So when it comes to pre-training data, there's always this kind of trade-off between quality versus quantity. So do we want more data or do we want good data? Ideally, we want to have them both, but most of the cases we can't. So in this case, the conclusion basically of our experience was that we really focused on high-quality data. And in the medical domain, high-quality data means that we included in the pre-training mixture clinical guidelines, which is basically the up-to-date information for every doctor to do diagnosis. So we can, let's say, draw conclusions. If we want to do the same in the financial domain, we can, for example, include financial documents in order to have this kind of like domain terminology included in our model. Also, definitely mathematics, to have the arithmetic reasoning, and maybe news articles that have, from good sources that have this kind of like event extraction and reasoning between the causality, let's say, of the events that took place. So these are, I think, also mixtures that they were used in Bloomberg GPT. So that would be really good additions to how we design this kind of the mixture that's going to serve as our pre-trained data. So when it comes to pre-training, we used an existing base model, which is the Llama 2 70 billion model. And basically, the idea is very simple. Every model used in an autoregressive way, as we saw from the previous presentations. So we only want every time to predict the next token, the next word, okay? So here, one of the biggest lessons we learned is that parameter size matters. That means that we ran some experiments on like a smaller model on 7B, that the base model was Llama 2 7B. But we saw really this kind of emerging capabilities of these kind of models the moment we scaled. So it's very interesting to actually see how these models perform and how more, let's say, complex reasoning can do when we increase the parameter size. Finally, when it comes to evaluation, We use various benchmarks, some domain-specific benchmarks that, in this case, was in medical. I think it was medical test taking. And some general benchmarks to test the abilities of the model, general abilities of the model, like common sense abilities or arithmetic reasoning. And then we did also some human evaluation, which was one of the most interesting evaluation methods that we had. The most important thing that the takeaway, let's say, from this process that can be applied to any kind of models that we want to align them in a specific domain is that we want to bring the evaluation closer to the end task. That means that it's really nice to test models in very synthetic scenarios, maybe in like logistic regression scenarios, or maybe when we have annotated data that are very clean without the noise, but we want to bring them closer to what will these models actually be used on and how these models will be deployed on. So if we see here, this is again from the Bloomberg GPT paper. They basically evaluate the whole model, which is like, it was an expensive model to train on public data sets on name entity recognition and sentiment analysis. So if there is one thing that I want you to remember from this talk is that currently there is a huge need for benchmarks, especially in the specialized domains like medical or finance, that test real-world tasks and scenarios. Because again, we want these models to be used by practitioners in real-world tasks. So so basically what we try to develop in my lab, and we have a bunch of different evaluation metrics and evaluation methods and benchmarks. So we focus also on causal reasoning, which is a very important skill that we want the models to have, on common sense reasoning, and also on methods of how we can augment our data in a synthetic way in low resource settings. So here is like some papers that we have published the previous year, and I'm going to briefly talk, I think, how much time do I have? Okay, perfect. I'm going to briefly talk about one of these benchmarks that I think is very related to people that they want to extract events from raw text and understand causality between these events. So we have created a test bed that basically has more than 2.7K of annotated data pairwise causality scores between events. So we parsed news articles and we extracted events, main events that are these news articles, and then we passed them both through crowdsourcing and human experts in order to understand the causality between these events. I think this is very important for any kind of free text, either, let's say, transcripts for interview with a CEO or something, of how we can extract events, but not just extract them, but understand the connections between them. Because by understanding the connections between between events and a narrative, we basically understand the narrative. So yeah, you can find all these benchmarks and methods in our lab's website, and also we have published all these as papers. So yeah, thank you very much. I hope I'm on time. Thank you.